Good morning, students. Yesterday we left at the concept as work function. Today we continue the term the work function of a metal. How to define this work function of a metal? This work function of a metal is different for different metals. Here let us consider the example as can consider one metal. Whatever it is the metal, this metal is consist of an infinity number of atoms. Infinity number of atoms are there. For our convenient learning or convenient explanation, I have considered only 4 atoms. Each and every element or each and every metal consists of infinite number of atoms. I considered one element or considered one metal, whatever it is. It may be a cesium metal, it may be a platinum metal, it may be a copper, it may be a gold, whatever it is. I don't know the name of this metal, but just I generally consider one metal now. It is consisting of infinity number of atoms. For our convenience, I considered only 4 atoms. You know very well, each and every atom is neutral number. What is the reason? The number of positive charges at the center is equal to number of negative charges. Number of positive charges means they are protons which are present in the nucleus. That is exactly equal to the number of electrons which are revolving around the nucleus in their orbits. That's why number of positive charges is equal to number of negative charges. The number of protons is equal to number of electrons. That's why each and every atom is a neutral one. This atom is also neutral. This atom is also neutral. All the atoms are neutral means the total net charge of this metal is also neutral one. Now, in order to study the work function as a concept, our intention is to how to understand this one. Here, our intention is to let us consider these are the outermost electrons of each and every atom. Now, our intention is to emit the electron from the surface of the metal. Then what to do now? I am applying until and unless you are supplying some external energy to the atoms, these electrons are not ejecting from the surface of the metal. Then what we can do? Then I am supplying some external energy. I am supplying some external energy. That external energy I am taking it as a heat energy. This energy I am taking it as a heat energy, or we can call it as thermal energy. Thermal energy means that is heat energy. You know very well the general sentence, that is the general concept. What is the relation between temperature and kinetic energy of the particles? That is directly proportional to each other. If the temperature goes on increases, the kinetic energy of the particles of the atom is also goes on increases. Here I am applying heat energy to this metal. However, I am applying the heat energy to the metal, then the kinetic energy of this outermost electrons goes on increases. However, the kinetic energy of this outermost electron goes on, outermost cells goes on increases. These electrons, this electron become free from the electrostatic force of attraction by the nucleus, and it is become free and hitting to the another electron of another atom. And whenever this electron transfers its kinetic energy to the another electron, this electron also become free, and again it is hitting to the another electron of other atom. This process goes on continuous. But here you can observe carefully, this electron is colliding with other electrons continuously, but it is not emitting from the surface of the metal. Our intention is to what? Our intention is to emit the electron from the surface of the metal, but this electron is colliding with other electrons, but it is not coming out of the electron. But what to do now? In order to take the electron, or in order to emit the electron from the surface of the metal, then what you need to do here? You need to increase the kinetic energy of this electron further. Then what to do now? Then you can apply or you can increase a more heat energy which is supplying to this metal. However, you are increasing more energy to the metal, then automatically the kinetic energy of this electron is also increases, and finally this electron is just coming out of the metal, and whenever this electron is just coming out of the metal, in that place there is a creation of positive charge. Get it? For example, if two electrons are coming out, means there are two positive charges, they are creating itself in the metal now. Whenever you are increasing the heat energy, the kinetic energy of this free electron increases. Finally, it is vibrating like anything and trying to come out from the surface of the metal. Just you can assume, if this electron is just coming out of the metal, in that place there is a vacancy. That vacancy is acted as a core. Core means there is a positive charge. Whenever this electron is just coming out of the metal, this created a positive charge. Again, it is attracting electron back to the metal. Then finally, what had happened here? This electron is not emitting out of the metal. Then our intention is to what? You need to emit the electron from the surface of the metal. Then what you need to do? You again increase a further heat energy. If you increase further heat energy, then the kinetic energy of the electron again increases. Then that kinetic energy helps the electron to escape from the surface of the metal to overcome the attraction by the positive charge in the metal. Whenever this electron is just coming out of the metal, if its kinetic energy increases, it overcomes the force of attraction by the positive charge, and finally this electron is coming out of the metal. Then here finally the electron is ejected from the surface of the metal. Then what is the reason became for this one? In stepwise, you increases the external energy applied to the metal. Finally the electron is coming out. If you apply less energy, then the kinetic energy of the electron becomes very less, and this electron is trying to come out from the surface of the metal. Then it is not possible for the electron to come out. Then next what we did here, you are applying some more external energy, and kinetic energy is again increases. Then there is a possibility of the electron coming out of the metal. That's why here the work function of each and every metal, or work function, it is the term can be defined as, it is the minimum energy. How to define this one? It is the minimum energy required for an electron. For example, if you apply 1 joule of heat energy, then the electron is not coming out of the metal because its kinetic energy is very less. If you increase 2 joule, then its kinetic energy again increases. Then it is trying to come out of the metal, but it is not possible for it. Next, you can apply 3 joule of energy. Then just can imagine, at the 3 joule of energy, if the electron is coming out of the metal means, then 1 joule, 2 joule, 3 joule, among these 3 energies, what is the minimum energy required for the electron to come out from the surface of the metal now? That is 3 joule. This 3 joule of energy is called as work function of a metal. For example, first you apply 1 joule, it is not coming out of the metal. You apply 2 joule, it is not coming out of the metal. If you apply 3 joule, at the 3 joule of energy, it is ejected from the surface of the metal. That is, among these 3 energies, which is the minimum energy required for the electron to come out of the metal? That is 3 joule. For 1 joule, it is not the work function. For 2 joule, it is not the work function, because at these energy, the electron is not ready to come out from the surface of the metal. For what minimum energy the electron has to come out from the surface of the metal? That is 3 joule. This 3 joule of energy is considered as the work function of this electron, or the work function of this metal. That's why how to define the work function of each and every metal? That is, it is the minimum amount of energy. This is the minimum amount of energy required for an electron. Minimum amount of energy required for an electron. For what purpose? To escape from the surface of the metal, from the surface of the metal, from the surface of the metal. This energy is called as work function of a metal. This energy is called as work function of a metal, that is indicated as work function of a metal, and this work function of a metal is denoted as pi naught. It is indicated as the symbol pi naught. Now here let us consider what is the SI unit of this work function. Next, that is considered what is the SI unit of work function. The SI unit of work function, you need to study this one out. The SI unit of work function is, that is electron volt. The electron volt is the SI unit of the work function. Generally, the work function of each and every metal can be measured in terms of electron volt. Getting? Here electron volt means, as you know very well, the electron, this E indicating the charge of elementary particle. The charge of elementary particle, what is the elementary particle? That is electron. Getting? That's why for each and every metal, the work function of that electron or work function of the metal can be measured in terms of electron volt. Generally, the work function of metal is measured in terms of electron volt. What is 1 electron volt is equal to? 1 electron volt is equal to, what is the value of this electron volt? 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule. This is the conversion of electron volt to joule here. The conversion of one unit to another unit, and E means, that is the value indicating the magnitude of 1.6 into 10 to the power of minus 19. This is, you know already, what is this magnitude? This is the charge of the particle. That particle is called as electron. Electron charge is equal to 1.6 into 10 to the power of minus 19, and joule came here. That is just a conversion from electron volt to joule. 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule. Now, further, in order to understand this 1 electron volt, you can take by example what is 2 electron volt. 2 electron volt is equal to, just 1 electron volt is 1.6 into 10 to the power of minus 19 joule, and 2 electron volt means you just can multiply 2 to this number. That is 2 into 1.6, that is 3.2 into 10 to the power of minus 19 joule. Again, 3 electron volt is equal to, multiply 3 to this number. That is, this process is continuous, but in order to measure the work function, we are going to use the term as 1 electron volt. 1 electron volt is equal to, that is 1.6 into 10 to the power of minus 19 joule. Now, and what is the definition of 1 electron volt? And next one, definition of electron volt. How to define 1 electron volt? What is the meaning of 1 electron volt now? Just you can define. Before going to the definition, you can understand some situations here or some terms here. Let us consider, these are all the negative charges. These are all the negative charges, and it is a positive charges here. Or else generally we can take, it is a negative plate and it is a positive plate. As you know very well, the direction of the electrical field is always from positive to negative. This is not a dipole moment. This is the direction of electrical field. The direction of electrical field is always from positive charges to negative charges, and the electron is always moving opposite to the electrical field. Get it? You know this one. The electron is always moving opposite to the electrical field because this negative potential repel the electron and this positive charges attract the electron. As you know very well, plus charges there is a repulsion, minus charges there is a repulsion, and minus charges there is a attraction, and plus charges there is a attraction. You know that one. That is very simple concept in electrostatics. Like charges always repel with each other, and unlike charges they attract with each other. Here this is the positive potential, means here the number of the positive charges are there, here the number of negative charges are there. This positive charge attract the electron. Why? Because the electron having the charge is negative. This positive charge attracting negative charge towards it, and this negative charge repel the electron away from it. This is simple one, you know already. Then from where to where, from what point to what point the electron is always moving. The electron is always moving, that is from negative plate to positive plate. What is the reason behind this one? Here the electron experience of electrostatic force of repulsion from these charges, and the electron experience the electrostatic force of attraction from these charges. And this plate attracts the electron, and this plate repelling the electron. That's why, what is the direction of acceleration of the electron? That is negative to positive. Or in other words, you can call it as the electron always accelerating opposite to the direction of electrical field, because this is the direction of electrical field, the positive to negative direction of the electrical field. In opposite to the direction of electrical field, the electron is accelerating. Let us consider here definition of 1 electron volt. We are going to study now. Let us imagine this is a A point and this one is a B point. Let us consider here electron is there. I am keeping the electron at the A point. Let us imagine at the A point the electric potential of this electron is 1 volt, and if you keep the electron at the B point, its potential is equal to 2 volt at this point. The electron has the potential at the A point is equal to 1 volt. Just you can imagine to understand what you mean by 1 electron volt. Just you can imagine 2 points. This is A point, this is B point. At the A point, its potential is equal to 1 volt, and at the B point, its potential is equal to 2 volt. What is the potential difference between A and B? The potential difference between A and B is 2 minus 1 is equal to what? 1 volt. Then if the potential of electron at A point is equal to 2 volt, and if the electron has an electric potential at the B point is equal to 3 volt, now you can tell what is the potential difference between the A point and B point. That is 3 minus 2 is equal to what again? 1 volt. Generally what we are going to tell here, the electric potential difference between A point and B point, that is 1 volt. Always in order to define 1 electron volt, it is 1 electron volt can be defined as it is the kinetic energy gained by the electron. It is the kinetic energy gained by an electron. What is the meaning of kinetic energy? Where the electron possessing the kinetic energy. As you know very well, potential energy, that is the energy possessing whenever the particle is at rest, and kinetic energy is the energy it is possessing to the particle whenever the particle is in motion. And here the definition of 1 electron volt, it is 1 electron volt is the kinetic energy gained by the electron. Kinetic energy is the term here K means electron is in rest or whether it is in moving. The electron is in moving because we use the word as kinetic energy. whenever, until and unless it is becoming in motion, it doesn't possess any kinetic energy. Instead, it is having a potential energy. You use the word here kinetic energy means the electron it is accelerating, means it is moving from one point to another point. It is the kinetic energy gained by the electron when the potential difference, or it is the kinetic energy gained by the electron through a potential difference of one volt. Through a potential difference of 1 volt, that kinetic energy is called as then this kinetic energy of the electron is called as 1 electron volt. What is the condition here? The condition, this is a A point, this is a B point. For example, this is having a negative potential, this is having a positive potential. I am keeping the electron here. This electron is moving from A point to B point. Must and should condition should be potential difference between these two points is equal to 1 volt. A ಮತ್ತು B point ಕಡೆಗ potential difference 1 volt ಅನ್ನ ಇರಬೇಕ. ಅವಾಗ ಎಲೆಕ್ಟ್ರಾನ್ A point ಇಂದ B point ಗೆ ಮೂವ್ ಆಯ್ತಂದ್ರ ಅವಾಗ potential difference ಎಷ್ಟದ A ಮತ್ತು B point ಕಡೆಗ that is 1 volt. Whenever the potential difference between these two points become 1 volt, then electron is moving from A point to B point. Whenever it is moving, then it is having some kinetic energy. That kinetic energy is called as 1 electron volt. The potential difference between A point and B point must and should be 1 volt. It is not up to volt. ಎರಡು ಪಾಯಿಂಟ್ ನಡುವೆ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ 1 ವೋಲ್ಟ್ ಇರಬೇಕು. ಅವಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಮೂವ್ ಆಗುತ್ತೆ. ಎಲೆಕ್ಟ್ರಾನ್ ಮೂವ್ ಆದಾಗ ಅದಕ್ಕೆ ಸಿಗುವಂತ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಏನಂತಾರ, that is 1 electron volt. That's why generally it can define as it is the kinetic energy. 1 electron volt is the kinetic energy gained by the electron whenever it is moving from one point to another point with the potential difference of 1 volt. Getting? That is called as the definition of 1 electron volt. And generally, this electron volt is a unit we are not using to measure the work function. And electron volt is the SI unit. It is also used in atomic physics and as well as nuclear physics. Getting? This is the definition of 1 electron volt. You remember that one. And next, the work function of different metals. The work function of each and every metal is not same, because you take the example as cesium metal. You take the example as cesium metal. Let us consider it is a cesium metal. Here one electron is there. Inside the cesium metal, one electron is there. I am applying only 1 joule of energy. Just you can imagine, it is not an exact value. Just I have taken it for reference. I am applying only 1 joule of energy, then immediately electron is coming out. Then immediately its kinetic energy is suddenly increases and this electron suddenly emitting from the surface of the metal. Getting? Means what you have to observe very clearly here, in order to emit the electron from the surface of the cesium metal, the work has to be done by the electron is very less. Getting? ಈ cesium metal ದಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಹೊರಗೆ ಬರಬೇಕಂದ್ರೆ ನಾನು ಓನ್ಲಿ 1 joule of energy ಅನ್ನು ಕೊಟ್ಟಿದ್ದೀನ. ಅವಾಗ ಓನ್ಲಿ ಫಾರ್ 1 joule the electron is coming out of the surface of the cesium metal. Take another example, that is silver. Take another example, that is silver. Here it is also having the same electron. Same electron ಇದರಲ್ಲಿ ಇರುತ್ತದೆ. There is no changes in the electron by different elements. Getting? Let us consider I am applying 1 joule of energy. Then whenever I am applying 1 joule of energy to the silver metal, then the kinetic energy of this electron is increases. But this electron is trying to come out from the surface of the metal, but it is not possible for this electron to come out from the metal surface. its kinetic energy is increases. This electron is vibrating, its kinetic energy is increases anyway, but this electron is not coming out of the surface of the metal. Then what to do next? I am increasing some more energy. That is, for example, you can take, for example, I am increasing 2 joule. 1 joule to 2 joule I am increasing heat energy. I am supplying external energy furthermore. Then what is happening here? Again, whenever you are increasing the energy, its kinetic energy again increases. If the kinetic energy goes on increases, finally this electron is coming out of the getting this silver metal. Then just you can observe here, for only 1 joule of energy the electron is emitted, and here for the same energy this electron for the silver metal is not ready to come out of the metal. Then what we have to understand this one? For each and every metal, this work function is not same. Getting? That's what, for each and every metal the work function is different. Getting? We are giving some examples. By giving some examples, see those examples. That is, first one is a cesium. Okay, we will continue in the next class. The work function of each and every metal we can continue in the next class.